In this section, we're going to talk about how to solve linear congruences. Linear congruences are congruences of the form AX is congruent to B mod M. Here, the idea is that we want to find all the values of X mod M that satisfy this congruence. And it turns out that these linear congruences will not necessarily always have a solution. It turns out actually sometimes they'll have multiple solutions mod M. And when we talk about solutions, we're talking about equivalency classes, congruency classes mod M. So let's get into an easy example here. Let's say I want to solve 5x is congruent to 2 mod 7, just to make one up where we can just do this by hand. What we're doing is we're trying to look for the numbers 0 through 6. We're trying to figure out which of those are going to work for us for a solution to this congruence. We kind of, when we work with mod 7, remember formally what we're doing is we're working with the quotient set of the equivalence relation where two integers are congruent if they're equivalent mod, two integers are equivalent if they're congruent mod M. So here if we're working mod 7, then that's what that is. And so the only possible values that you can get, there's really only 7 different equivalency classes corresponding to the 7 different remainders that you get when you divide an integer by 7, namely 0 through 6. So essentially, we're just working with the entire set of integers, and we're thinking of all the integers as falling into one of 7 classes. Okay, so 0, 1, 2, 3, 4, 5, or 6. So when we solve this, what we want to do is we want to figure out which of those 7 numbers, if any, solve this equation. And so you can check when you plug in x equals 0, you're going to get 5 times 0 is 0. So that's not congruent to 2 mod 7. 5 times 1 is 5. That's also not congruent to 2 mod 7. 5 times 2 is 10. 10 mod 7 is 3. So that's not going to work. 5 times 3 is 15. 15 mod 7 is 1. This one will be, so 3 kind of plays the same role as 1/5 does when we're solving these equations, right? If we multiply both equations by 1/5, then you can solve it. So notice that we could do that. So we'll come back to that idea in just a second. But 3 itself is not a solution. I'm going to cross this off with a slightly different color because 3 is special for us. So we'll come back to that in a second. 4 times 5 is 20. 20 mod 7 is, let's see, 20 mod 7 is 6. 5 times 5 is 25. So 25 mod 7 is 4. And 6 times 5 is 30. 30 mod 7 is 2 because it's 28 plus 2. Good. So 5 times 6 is 30. That's 28 plus 2. So 30 is a multiple of 7 plus, 30 is a multiple of 7 plus 2 is what I mean to say. So you can check that when you take 5 times 6, you're going to end up with 30, and 30 is congruent to 2 mod 7. Okay, so here's our solution. So it turns out that the solution there is going to be 6. Now, the reason why I highlighted 3 before is that 3, it turns out, is what's called the multiplicative inverse of 5 mod 7. In other words, it satisfies this equation that 5x is congruent to 1 mod 7 if x is 3 mod 7. Okay, and so what we could do is we could use this fact. Once we have this multiplicative inverse, we can use it, and we can basically take the same strategy as when we're solving the regular old high school algebra, whatever year, kindergarten, 8th grade, I don't know what year people do anything, but 4x equals 11. When you solve that equation, you sometimes think of this as dividing both sides by 4, but we've already seen that dividing congruences are a problem, but multiplying is not. So what you can do is you can multiply both sides by the multiplicative inverse of 4 if it exists. And we'll talk about when that happens. So you would end up with, in our case, 1/4 times 4x equals 1/4. times 11. And then from there, you know that 1/4 times 4 is just x. That's the whole reason why we picked 1/4. Is you end up with x is 1/4 of 11, or 11/4. And so what you do when you're solving linear congruences is our strategy will be the same. We want to figure out what's the number that we have to multiply 5 by to get 1 mod 7. In our case, that is 3. So that 3 is going to play the role of the multiplicative inverse of 5 mod 7. And so what we can do is if we take 5x is congruent to 2 mod 7, which was the congruence that we started with. Okay, so that's this congruence that we started with here. What we can do is we can multiply both sides by 3. We've seen that 3 is special. So we can take 3 times 5x is congruent to 3 times 2 mod 7. And then 3 times 5x. Well, we've seen that 3 times 5 is 15, which is 1 mod 7. So 15x is actually the same as x mod 7, and you end up with x is 6 mod 7. So there's another way to get your solution. Okay, and so we'll put this all in a systematic framework, talk about our strategy. We're really going to focus in on how to find multiplicative inverses of a number mod 7 and when you can do that, when you can't do that. And so we will get into this in the coming section.